thank you all for coming to this session today. My name is Cornelia Davis. I've been with Pivotal since the spinoff. I imagine I know some of you. I have been part of the Cloud Foundry product team for the last 5+ years and worked on Cloud Foundry even before that when I was in the corporate CTO office at EMC doing architecture and emerging tech. I spent the first 3 or so years after the Pivotal spinoff really focused on what was PCF. Well, it wasn't even PCF, Cloud Foundry, and then became PCF. And then I spent about a year really focusing on Pivotal Cloud Cache, and for about the last year, I've been really focused on PKS. So this new emerging technology of Kubernetes, what does it mean for the enterprise, and really trying to help kind of our market and our customer base embrace that and learn from all of you on, and then bring that back into the product. And so today is going to be talking about some of that insight as we go along. And my co-presenter?
Hi, I'm Mukesh. I am one of the product managers on the PKS team in Pivotal. And prior to that, I was managing a product called as PCF Metrics, which was application monitoring and logging tool for Cloud Foundry application developers. Been in Valley for 6 years, been in tech for about 10. Really excited about Kubernetes and what it can offer to enterprise.
Yep. And part of the reason that Mukesh and I are pairing on this is I'm not very good at keeping all of my punchlines in check. So part of what we're going to be doing is talking about not just Kubernetes, but we're talking about containers. Notice that it doesn't say the value of bringing everything to Kubernetes. It says to containers. And so I asked Mukesh if he wanted to work on this presentation together, because at the time he was really focused and still continues to be focused on this what's the blending of our application service and our Kubernetes service, our container service. And so that's part of the theme that you're going to see coming out through this presentation. So without further ado, the safe harbor statement, although we aren't talking a lot of details on product here, but if there is anything that we mention about product, we're obviously doing our best. We're giving you the information as we know it, but it could change. We're a public company now. We have to make statements like that. All right, so where I really want to start with is this quote, and I'll read it to you. I want to move all workloads from V to C so that I no longer have to worry about doing things like patching operating systems. And this is a quote from a major US telco provider. And in fact, I ran into him this morning and said, you know that I'm quoting you today? And he said, please do. So he gave me permission to tell you who he is. It's Greg Otto. So many of you have seen Greg talk about the success that they've had with PaaS. And this is his vision. And what's interesting about this vision is that, and he himself went on, and this is a quote from a conversation that I was having with him many months ago, and he goes on to draw the parallels between P to V. So 20 years ago or so, virtualization, virtual machine technology, and I know it's about 20 years ago or so because VMware is just celebrating its 20-year anniversary, its 20th birthday. Virtualization technology, virtual machines came on the scene. Now, I'll tell you that I think I was among the group of individuals who were the first people to embrace virtualization technology. I'm a developer by background, and before that, I used to run around with 2 hard drives for my machine. I had one that booted to Windows, and when I wanted to boot to Linux, I had to shut down my machine, pull out that hard drive, pop in the other hard drive, I had my little screwdriver with me, and I'd boot up to Linux. Anybody else? Right? And then virtualization technology came along, and I no longer needed to do that hardware swap, right? I could just do virtualization. And part of the reason I mention this is because I think it's really interesting, the parallels that we're seeing now with containers. Because while arguably containers and Docker, really the movement has started with the developer community, just like with virtualization, I believe that the real explosion and the real huge value that we're going to get from containers is yet to come. And it's going to happen when we move it into our data centers and we move it into mainstream IT from being just a developer API. And that's what happened with virtualization. It was a developer tool that the developers started using so I didn't have to swap out hard drives anymore. And then about 15 years ago, we started seeing enterprises having initiatives that were called P2V. We're going to move everything off of raw hardware and we're going to move it all into virtualization. Now, in the beginning, everybody said, hey, I can only move 10, 15% of my workloads, and there were all sorts of reasons why they couldn't move anything else off of hardware, bare metal. And today, we're in a world where most enterprises that I talk to are 80, 90% virtualized. So what's interesting is right now, people like Greg already are 10 or 15% C. How's he getting there? Through PaaS, through PCF. And we'll talk about that containerization in just a moment. And what he is seeing is there's so much value in that, and he's realized that value with PaaS, that he wants to actually move the bulk of his workloads. Now, Greg is espousing this, very visionary. I've spoken with other customers. I have one customer in the financial services space who made that statement recently, and he added to it by saying, I want to move 80% of my workloads into containers in the next 3 years. I think it took most enterprises 10 years to get there with virtualization. He wants to accelerate that. So what we're going to be talking about today is, what does this mean? What does this look like? How can you get there? And mainly, what are the benefits of containerization? And how can you get there? So to that extent, here's our agenda. We're going to spend a little bit of time talking about containerization. Now, I know you all know what basic containerization is, but bear with us because we're going to give you this perspective. We're going to talk about containerization from the perspective of where we're going for the entire talk. Then we'll talk about kind of the vanilla benefits of containerization, and then we'll start to talk about the different phases of containerization and how those different phases can give you even more benefits. So that's where we'll spend a fair bit of the time. And then, because there are different phases of containerization, different ways of realizing containerization, the question then is, which one do I use when? And we'll spend some time talking about what the right abstractions are for your particular workloads. Now, I mentioned that both of us, in fact, are working on PKS. And so I know that there's some folks in the room who probably haven't been exposed to PKS. So at the end, we're going to spend about 10 minutes introducing those of you who are new to PKS, and then really focusing on what the differentiators of PKS are over some other Kubernetes distributions. It's really going to kind of give you an idea of what our philosophy at Pivotal is around Kubernetes and what we think the most important things are, all in support of this vision of moving everything into containers. All right.
Thank you, Cornelia. The bar is set really high. I hope to continue that. So when Cornelia and I started talking about what do we want to present, in this context, I started penning down my thoughts on maybe we should start talking about what are the benefits of containerization. So I started writing the things that I see are the benefits, and I said, you know what, maybe let's step back and let's really start from the basics. So what is a container? And I'm curious if anyone wants to take a shot at answering that, because it's a really abstract concept. Anyone? It's a time for you to get famous.
It's all being recorded.
No one? All right. Container doesn't really mean anything precise. It's a thing that you call as a container when you use, and this is a few years ago, Linux kernel features of C groups and namespaces. C groups for process resource accounting metering, and namespaces for isolating processes running on the same OS. So that's so when you use when the container runtime uses these features, that's what you call it. So a little bit of virtualization hierarchy differences between how applications are deployed on virtual machines versus containers. And this is an image that you will see in almost every web page if you search for container versus virtual machines. So it's a pretty common image to describe the difference. So the biggest difference here is all containers share the same OS and the kernel. And it's the container runtime that's the magic sauce that gives you that process virtualization that we just looked at as container level. All right, so now that we know a little bit about what the container is, let's talk about what is containerization. And so what I mean here is moving from a traditional way of deploying your application on virtual machines, like what does it take step by step to containerize your application. So it all starts with describing what all it takes to run your application. That includes the dependencies, configuration, and how would you start your application. So that's the Docker file for the Docker fans. And the building part is and that's the container runtime actually pulling all together these dependencies and images that it requires to actually build your application into something called as a container image. The second step is you ship the images and all the configuration that's required for running your application on containers as container image into something called as container registry. Right? A few years ago, like when the whole containerization movement started happening, there was only Docker Hub and Docker Trusted Registry. But over the last few years, there've been quite a few registries. Almost every public cloud has their own registry as a way to store the container images artifacts. The third step in the process is, and I'm going to relate again to the Docker run. So as a part of Docker run, there's Docker create and Docker start. So the Docker create, when you do a Docker create, the container gets created and it's extracting all the images from the registry onto the file system on which the container is going to be created. And the beautiful part of this is, if you're running hundreds of containers on a single server, a lot of those containers may share certain images like Ubuntu or Python. And so when you're extracting all these images, a lot of these base images are actually shared for all of these containers. So at the top, you have a thin read and write layer, and that is for your own container to write any data, like ephemeral data, but everything else below is actually shared by all the containers, unless the container needs to modify it. And so this really, this is copy and write protocol that is advantageous because you're really efficient in how you're using the disk. And then the fourth step of the process, going back to the container runtime image, is the container runtime is the magic sauce, like secret sauce, that's actually using the Linux kernel features or the kernel features, C groups and namespaces to have the process isolation and run the container within, right? So you have the red boundaries are actually created by the container runtime, right? So these are the 4 steps of creating and running containers or containerization. And so now that we know what a container is, how do you move from virtual machines to containerization? Let's talk about the benefits of containerization. First is consistency, right? When you have hundreds of development teams, you want to have a standardized way of packaging your software so that you don't need to retrain like each team on something else, or not each dev team is actually creating a different way of packaging. So this is more of a consistency that all your development teams can actually follow, and you have a consistent app deploy model that packages all of your dependencies, including your application source, into a container image. Because of that, the biggest benefit is you build a container image once and you run it anywhere. And the benefits of running anywhere means you're not running into a situation where a developer says, it runs on my machine, but the operations team says, oh, it's not running on production. It's the same container image artifact that is run across all the environments. So you have very less environment snowflakes. And this is sort of side effect of how container image artifact separates the concerns from development, where the developers are essentially incorporating all the dependencies into one package and then hand it over to the operations in the traditional way of development and operations. And then operations is just going to take care of the container management orchestration layer and not necessarily worrying about what's the coupling or what are the dependencies, are the dependencies right on the virtual machines or not. The second is agility. So containers, if you recall, do not have the guest OS. Like it's the kernel features of C groups and namespace that's actually giving the virtualization are very lightweight. And because they're lightweight, they're very fast to provision, right? Creating a VM versus creating a container, it's given that it's really fast to provision a container. What that results into the app deployments being a lot faster than doing it over the virtual machines. Because containers are lightweight and smaller, it enables development teams to focus on how do you convert your monoliths into microservices architecture. Containers are lightweight, that's why you can horizontally scale your applications. That's another advantage of microservices architecture. So containers actually enable teams to adopt microservices architecture. And back to the lightweight being, because containers are lightweight, they can be horizontally scaled, and so handling traffic spikes, which are unpredictable in nature, containers are better suited to handle that versus virtual machines. And container images, again, because you have a standard artifact on how the app is deployed, your CI/CD tools can actually take up the container images, move it to the development lifecycle of testing, canary deployment, etc. So because you have a single artifact that describes how your application is run, it really streamlines CI/CD workflows. And the last is efficiency. Because containers are small compared to the virtual machines, the number of containers that you can run on physical servers are a lot higher than virtual machines. So you get a lot more server density compared to virtual machines. We looked at the copy on write protocol and how it actually enables you to have efficient disk usage because the images are shared across containers. And the last bit is because containers are running on a shared OS, the process of OS patching compared to virtual machines where OS is actually part of the virtual machine, where if you want to patch an application, you have to go all the way to the host OS and patch the OS. Whereas containers, the OS is shared, that's why it results into efficient OS patching process. All right, so that gets us to the different phases of containerization that Cornelia can walk us through.
Great. Thank you, Mukesh. All right. So I want to come back to Greg's quote. I want to move all workloads from V to C so that I no longer have to worry about things like patching operating systems. Now, the reason that Greg recognizes patching operating systems as one of the benefits of containerization is because he's already realizing that. So let's zoom in on that one in particular, but then I'm also going to explore a number of other likes. What other things can you get beyond patching operating systems? So let's start with this one, though. So based on what Mukesh showed us already, Basically, the way that containers work are that you've got a host. It's usually a virtualized host at this point because most everything's virtualized. I've got a host which has an operating system already built into it. And that is something that our platform does. We embed the operating system. That's extremely important because we'll talk about that as we go through these builds. And then on top of that, we end up with a container. And based on what Mukesh told us is that we've got different layers in that container. Now those different layers, to a large extent, if I'm just simplifying it a little bit here, simplify down into the 3 layers. One is the root file system. Next is essentially a whole bunch of runtime stuff, your JDK, for example, and then the application itself. Now, because PCF embeds that host OS, what that allows us to do is it allows us to repair that host OS through automation. What happens here, and can you imagine, for example, addressing Meltdown and Spectre within 16 hours? And there's a blog post there where we did exactly that on Pivotal Web Services. Now, how does that work? And I know that there's some of you who are probably more of a Spring background than a Cloud Foundry background. For those of you who know Cloud Foundry and know how this works, bear with me for just a moment. What we do here is that PCF, as I said, embeds the operating system. We call it a stem cell. So when you're doing a platform deployment, you are deploying a stem cell as a part of that. Who do you get the stem cell from? Us. What we've done with that stem cell is we've done the exhaustive testing, and we have an entire security team that is constantly assessing CVEs, putting them through a funnel and doing a categorization on what the severity level of those CVEs are. If it is a severe CVE, it goes top of backlog for the team that generates the operating system that is part of the host. Because in the platform, we're managing the host. We create the host, we manage the operating system on the host, and so on. So when we get that CVE, it goes top of backlog, and within 24 to 48 hours, there is a new version of the stem cell available on our distribution platform, on Pivotal Network. What you do then is you simply download and upload. Likely with automation, our most advanced customers actually have pipelines that trigger off of events in Pivotal Network. Pivotal Network will send out events when there's new things uploaded there. They will run those pipelines, which will download and then upload into the platform the new stem cell, and then they essentially push the apply button, either by a human or by automation. And what we do then is we do a rolling upgrade through every single node. Now contrast that to the traditional ITIL-based approaches, which involve configuration management databases. Then you have to go through and understand which OSs, which machines are running which OS. Then you have to decide, you have to figure out which apps are running on those hosts. Then you have to go talk to those operations teams to make sure that do they need a zero down, do they need a maintenance window, et cetera, et cetera. We just do this. So we just patch the operating system. And that's the experience that Greg has had. And that's the experience that he's talking to. He's saying, in a virtualization world, I have to worry about the OS. I don't want to worry about the OS anymore. That's part of the platform. Now, the astute of you, all of you, are noticing that I'm pointing to the kernel OS. And you might be thinking, well, what about the OS image? What about the root file system that's inside of the container? What if there's a vulnerability in there? So let's talk about that. Now, before I drill into the details of that, I want to take an aside here for just a moment and talk about a couple of different personas. What we have here is we have the application team, and the application team is responsible for essentially iteratively building out their application and deploying it on the platform. And the platform team is responsible, they're the ones that are ultimately responsible for the type of security that I'm talking about here. They're responsible for the CVE management and upgrading that operating system. So why am I bringing up this picture right now when I'm talking about what's in the OS? Didn't Mukesh talk about the fact that containers give us this separation that allows the developer to just build the container and allows the operator to just run the container? Well, it turns out that it's not actually quite that simple. So if we go back to this picture, what we can see here is we've got all the layers, and what we suggested was that the developer is responsible for all of the layers that are inside of the container, and the operator is just responsible for running this black box container. Well, how many of you are going to let your cowgirl and cowboy developers who are like, I don't know about ops, just hand you an image and you're going to go ahead and run it on your production systems? Probably not very many of you. So over here on the other side, we have the platform team, and I'm waiting for the right click, who says, not so fast, my friend. Any Saturday morning Lee Corso watchers? Not so fast, my friend. My husband's a big football fan. This individual here, the platform team, is responsible ultimately for the security, for keeping you out of the Equifax-like headlines, right? So she's saying, not so fast, my friend. I need to have control over some of this stuff. I need to have control over the operating system, not only at the kernel level, but inside of the image as well. And I want also to have control over addressing vulnerabilities in, let's say, the JDK or the .NET framework or something like that. So these are the things that I want to provide as a platform team. And then you just give me the application layer. So wait a minute, did we just blow things up here? Did we just invalidate something that Mukesh said? It actually turns out that I picked up a term from one of my customers who refers to this process of generating the container image as the trusted container pipeline. So you have to, if you're doing containerization, it isn't as simple as saying, hey, I'm just going to take what the developer gives me, because you have this overlap of responsibilities on who's responsible for things that need enterprise control. Now, I'm going to talk about it in a little bit later, but this is a good place for me to point to the picture. On the left-hand side, you have a picture that looks a little bit more like raw Kubernetes usage. The trusted container pipeline has to be done on the outside. On the right-hand side, you have something that looks a lot more like PaaS. PaaS takes care of this trusted container pipeline through build packs. The developer just gives you the code, and the platform itself generates the container with this profile. Again, that's what Greg means by, I no longer want to have to worry about things like patching operating systems. So what this allows us to do then, on the left-hand side, if we've got that picture, I can repair, so when I have CVEs, I can repair the kernel OS. Over here, I can repair everything up to, but not including the application. The application team's only responsible for the application. All right, so that's exactly what he means by patching operating systems. Now, what else? Well, what about malware? That's another thing that Greg would rather not have to worry about anymore, or certainly worry about less. So let's go back to our picture here. We have the image, it's running in production. It's out there, the container image is deployed, and we have a container that's running the code. And along comes a bad guy who injects malware either into somewhere inside of the container or injects malware onto the host. And then he disappears, because if he stays, we might notice him, but the malware maybe won't get noticed. So now you're running like this, and the malware's sitting in there just waiting for a moment, waiting for an opportunity to exploit. And that right now you're exposed. So what our customers are doing, what Greg and many of our other customers are doing, is they're recognizing that one of the best ways to create a secure platform is to change it all the time. I can't be perfect. I can't keep all the malware from coming in. But I have a customer who is repaving, that's the R the R word that I'm looking for, who's repaving twice a week. And let me show you what repaving looks like. We're going to go back to the benefits that Mukesh talked about. What we can do here is we can say this. Every X number of days, once a week, once every 3 days, I am going to just kick this image out. I'm going to kick this container out and replace it with a new one. Containers enable that. Remember what Mukesh said? You can spin them up fast. You can spin them up identically every single time because the container image is just getting deployed. So it's exactly the same deployment. That's what enables me to very quickly kick out, just dispose of that. It may have malware on it, it may not. Doesn't matter, I can just replace it. Well, what about the host OS? Well, as it turns out, our PKS, our PAS deployment, because we manage the hosts themselves, we have the ability to do this at the host level as well. Create a new host and repave those hosts every 3 days. This one customer that I'm referring to, he's currently doing it every 3 days. He's completely repaving his platform every 3 days. So if malware made it in, the longest it can live in there is 3 days. I just talked to him yesterday, he's going to up that to every day. So what you can do is you can repave the environment and you can repave it very often. That's what Greg's talking about. I don't want to have to worry about malware anymore. All right, so that's malware. What's next? Another one, prediction-based capacity management, right? So how did we do this in the past? Well, 6 months or 9 months before we went into production, we would do some analysis on our predicted workloads, and then we would size everything based on that. Initially sizing hardware, eventually sizing virtual machines. And then because we'd be in a heck of a lot of trouble if we were too conservative, we double that. And so what do we end up with? A whole bunch of unused capacity, right? But that's the way that we've been doing things, and quite frankly are still doing things in a lot of places. How do containers help me with this particular problem? Well, it's actually pretty straightforward. I've got my workloads that are running out there. I've got multiple workloads. And notice there that I've got enough capacity left over. And I'll talk about that more in just a moment. If I need more capacity at the application layer, I just go ahead and I scale up. It's what Mukesh was saying earlier. I scale out those workloads. I add additional instances. Well, what if things start getting full on the host like you see here? Again, because of the way that our platform works, because of the Bosch layer, I made it this far into a talk without saying Bosch. I'm the biggest Bosch fangirl out there. Bosch will go ahead and provision a new host that I can then deploy additional workloads on. So again, going back to what Mukesh talked about earlier, I don't have to do this predictively, I can do it reactively, I can do it dynamically. So as my load increases on my end user applications, I can go ahead and auto-scale instances of those containers. All of those platforms, PKS, Kubernetes does auto-scaling, PAS does auto-scaling, PFS does auto-scaling. So it's the container technology that enables us to change the way that we think about capacity planning and go from a planning to more of a capacity management idea. Now, so again, that's exactly what I'm saying here, is going away from predictions over to on-demand capacity management. Now, I want to bring our teams back in here because you can say, Well, at some point, somebody needs to manage all of this. What if I don't have more virtualization space? What if I don't have enough hardware? And again, what we're doing here really is giving those different teams the controls that they need to be able to do that capacity management instead of well in advance predictive. And so, for example, the application team, they're responsible for monitoring the use of their application and scaling up and down as needed, possibly through automation. The platform team, same thing, except that they're not monitoring the applications, they're monitoring the platform. So they're looking at, am I at 60% capacity, 80% capacity? Am I at 20% capacity and I can scale down my deployment? Those types of things. There's a couple of important constructs you have to have, of course. So you have to have the notion of things like quotas, and you need really good monitoring and metrics capabilities. And so again, all of that can be automated. So that's what we mean, and that's what Greg means by a value like prediction-based, replacing prediction-based, not having to worry about prediction-based capacity management. And finally, I want to talk about one more, which is another one, is load balancer configuration. So in kind of traditional, and I call it imperative systems management, and by imperative I mean sequential. Do this step, do this step, do this step, do this step, control every single step in the process, and then at the end, when I come out of the bottom of my for loop or my series of statements, I'm going to be done. Well, what does that look like? How does that traditionally look? What's the workflow look like? Well, you need to first provision a machine, and yep, you need to file a ticket for that. And then usually there's some automation for provisioning. After you've provisioned the machine, you're going to install the operating system and some middleware. That's becoming fairly common in the enterprise now. Wasn't so 5 years ago. Then I need to install the application, and yep, that probably comes from a ticket as well. And then once the application's installed, I also need to configure the firewall to point to all those application instances that are in there. And yep, that's a ticket-based system as well. And then the process goes on, and then I'm done. Well, arguably, everything that I've talked about so far kind of was taken care of in some of the initial things that I talked about earlier. I can provision these instances, I can have the platform doing that. I want to do the same thing with the firewall. Now, how many of you have seen this slide with this template before? Oh, not that many of you. So as I was talking about this dynamic firewall configuration, I thought about drawing a new picture, and I thought, no, actually, I'm going to do like a Throwback Tuesday here. So this is, and that's why I kept the old Pivotal template, because these were pictures that we drew about Cloud Foundry 5 years ago. Now this one's a little bit newer because you can see that it says Diego on it. Originally we had this with, what was it before? DEA, thank you, threes. The DEA, and then we replaced the DEA with Diego. So this is our, Diego's of course the container scheduler. And so I just thought I'd share this with you because this was part of our 4 levels of HA that we talked about many, many years ago. So what we have here is we've got workloads that are running on the cells. And the way that the system works is it is this declarative model. So we've declared, I want 2 instances of this running. The actual state of the universe, 2 instances running, is constantly being written into the shared store, which is etcd. And the converger and auctioneer, the kind of the health of the system, is doing a comparison of those things, and everything is cool right now. And by the way, the load balancer's already been configured, and I can be accessing my workload here at this cell. And then something happens. This either has died, or I'm doing an upgrade, or if you remember a while ago, I'm repaving my system. So I'm just doing this proactively, whether I have malware or not, but if there's malware in there, I'm kicking it out, and I'm going to create a new instance. But that new instance doesn't necessarily land at the same exact location that it did before. So what's happening here is that the system recognizes that the actual state and the desired state have diverged, and the first thing it's going to do is it's going to let the router know, hey, don't send traffic to this node anymore because it doesn't exist. That workload's gone. No ticket, it's all done automatically. Now the converger and auctioneer is going to deploy the new workload, and the message is going to get back to the dynamic router. So in the past, when you deployed an application, you had to file a ticket with your F5 team to get them to wire things up. Well, in the cloud-native world, in the container-based world, things are changing. Even when you deploy to Kubernetes, you create a new instance of that app, it's very likely going to get a totally new IP address. So does that mean I have to go to my F5 team and have them change the load balancer rules? No. You need to have, again, you need to have that, and now I can route to that. I need to not have to worry about load balancer configuration anymore. So these are the types of things that Greg has in mind when he says, I want to move to containers. Now, when I say I want to move to containers, does that mean that those of you who have been doing Pivotal Application Service have to move everything over to Kubernetes? And the answer is absolutely not. So remember at the beginning I said that some of our customers are 10, 15% virtualized? What I meant by that was I talked to lots of customers where they're hugely successful with PaaS, and then I say, okay, how much of your workload, how much of your entire portfolio is now running on PaaS? And they say 10, 15%. And what they're looking, and what we're looking to do for our customers and with you, is to help bring you to that 80%. So the whole punchline there is, if you're already running on PaaS, you've already started your journey to containerization. There's many ways to get there. So I want to talk about the 3 abstractions. Some of you may have seen this, especially if we talked about these 3 abstractions even about a little less than a year ago at the last spring one. And that is starting with the raw container abstraction. Let's talk about what that looks like. And in fact, Mukesh already introduced this to us earlier. So the raw container abstraction in the platform requires that you start with a Docker file. Then you do a Docker build. Then you do a Docker push, as Mukesh talked about, up into the registry, the image registry. And then you want to do a deployment. What does a deployment look like? Anybody like YAML? So you have to craft a lot of YAML. And what I'm talking about here when I say raw container abstraction is I'm actually talking about Kubernetes. So you craft a bunch of YAML which describes your deployment. Points to the image, talks about some of the configuration around that. And then you do a kubectl apply. Okay? So it's a pretty raw protocol, and a raw way of working with containers. Now, I have to say this in every talk that I do around Kubernetes, especially for all of us who have spent the last several years working on something like PaaS, is that Kubernetes is sometimes marketed as kind of a developer productivity tool, but it's really an infrastructure abstraction. It's really an up-leveling of infrastructure because you're dealing with things like storage classes and network policies and those types of things. So it's really an infrastructure abstraction. So if you're going to be landing containers on Kubernetes, you have to realize that you are going to be dealing with infrastructure primitives. That's just the way it is. All right. So the application abstraction, I think many of you are probably familiar with. And everybody, let's do it together. Here is my code. Run it in the cloud for me.
Do not care how.
I do not care how, right? ANSI made this very, very famous. And by contrast to what we saw earlier, from a consumption perspective, my route as a app team, my route to getting this containerized, and Greg Otto's route to not having to worry about things like patching operating systems anymore, From the app team perspective, it's here's my jar file, here's my directory of Ruby code, here's my Go binary, here's a little bit of metadata, and I do a CF push. Different abstraction, different way of getting the container, but notice that with some differences, like we talked about with patching operating systems, there was definitely a difference, but all of the other things that I talked about earlier are benefits of containerization regardless of the abstraction that you use, okay? And then finally, I'll just say a few things about functions. So that's the logo for PFS. Of course, PFS isn't GA yet, but we have talked about it, and there's lots of sessions at the conference. And what I want to actually bring up is, who's heard of Knative? Most of you, that's good, not everyone. So for those of you who haven't, so Knative was introduced by Google at Google Next about a little bit more than a month ago. What Knative is, fundamentally, is this recognition of what I just emphasized a moment ago, which is that Kubernetes is fundamentally not a developer abstraction. It's an ops abstraction, it's an infrastructure abstraction. And what Google has said is, we see the need for having a robust and useful developer abstraction on top of Kubernetes. That's what the K is. So Kubernetes native. And here's our Knative page on our website, and I'll just draw your attention to the quote here. Pivotal is partnering very, very closely with Google on this. Frankly, Pivotal's been doing this for 5 years. We've been doing the developer abstraction on top of containers. Of course, Kubernetes didn't exist 5 years ago. And so we are partnering very, very closely with Google. And at Google Next, they're partnering with other companies as well. When I was watching the video of the keynote where they talked about it, they mentioned all these other customers, and I was like, where's Pivotal? We're here too. And then they brought Ryan Morgan on stage. I was like, oh, okay, there you go. So Pivotal is really kind of the premier partner of Google's in this whole Knative thing. And Knative is the basis of Riff. And so Riff, of course, is the foundation of our functions as a service. And what it does is it does things like container creation for you. So that whole picture of who's responsible for creating the container image, it does so. And then it also adds the whole eventing substrate to that. So it's yet another way of consuming containers. Of course, when you deliver, the developer now delivers a function, we create that as a container image and we run it on Kubernetes. All right, so those are 3 different abstractions, 3 different ways of getting to containers. So which one do you use when? And I'm going to hand it back over to Mukesh.
Thank you, Cornelia. It was very inspiring to hear you talk, especially describe the different personas that operate within an enterprise, and how they can have shared responsibilities, but still distribution of responsibilities, so that as an enterprise you achieve your goals of like speed, security, etc. It's really inspiring. Cool, thanks. All right, so as a taxonomy, you see 3 columns. On the left-hand side is the technology type. In the middle, the workload lifecycle and the value that workload actually brings to you as a company, and then team skills. And so there are some easy ones. And I'm wondering, based on what Cornelia has talked so far, does anyone have thoughts on what abstraction, application, container, or functions would this be in? Any guesses? Loud? There you go. Pivotal Application Service. And note that the microservices, Spring Boot, Go, whichever programming runtime you might use, .NET. I also have WebSphere and WebLogic. And what I'm trying to convey here is, even if some technologies are not suitable for PAS, if they are high value, if you want to release it often, focus on transforming them into something like microservices and run it in PAS because they are high value. The second taxonomy is anything that you don't write, right? Anything that you are taking either from a vendor, Jenkins, an example, or a stateful service, MySQL, Kafka, that you are not writing, but you're operating as a service operator. So your life cycle of updating the versions is actually tied to a partner life cycle. Choose Pivotal Container Service. All right, so this is an interesting one. Right? This is where we get asked all the time in customer conversations. Hey, there's Kubernetes. Kubernetes can run stateful, stateless. Why can't I just run that on PKS? And so the answer to that is if you're already in the containerization journey where the developers are actually building containers, and if you have expertise, if the development team has expertise in Kubernetes, Pivotal Container Service, is an example. And we have customers who have been successful with PAS, but there are certain development teams who already were on the containerization journey, were already exploring and using Kubernetes. Now you have an option to actually run it on Pivotal Container Service. But like Cornelia was mentioning, the dev team is responsible for the day two operations, and the day two operations, especially on image security, patching, etc. And that's the caveat that you have to be aware of. What about all the legacy stuff, uncommon runtime, COBOL, DB2, AS400, I don't know what else there was 20 years ago. Of course, those are hopefully in maintenance mode. You're patching them. You're not releasing it often. You're trying to move to the cloud native world. If you have a platform savvy and Kubernetes expertise, then PKS, Pivotal Container Service, is the right abstraction. And how can we not mention PFS since we are at Spring One? Right? So if you have web event like functionality that is part of our application that you can probably break it down into smaller functions, then PFS could be the right abstraction. All right, so tale of multiple abstractions. So this is the concentric circles with every abstraction listed here. What is the right abstraction? And let's look at IaaS. Right? So all of you who haven't really begun the containerization journey, whether through PAS, PFS, or PKS, you're still running applications on virtual machines. Right? So what are the pros? You obviously have access to OS. Right? It's not a shared OS like containers have. So you can customize OS. You can customize OS libraries. I put status quo in benefits because it doesn't require a change. What are the drawbacks? Right? The biggest drawback is you have the scenarios where things work really well on a developer's machine, or they really work in staging environment, but it really fails on production. And so that's goes back to the benefit of how container image as an abstraction to deploy across environments ensures the consistency. All right, sorry. Okay. Oops. Did I just go all the way? Oops. How do you go back?
Oh, there's back button.
Oh, there's back button. Okay. My bad. Okay, so that. Of course, the second one, and this again goes back to the containers are lightweight, so you can move them fast, whereas VMs are not. So the app lifecycle are definitely slow. And again, another one where containers, because they are lightweight, smaller, really supports microservices architecture, whereas VMs, they can, but the lifecycles events are really slow. So you will have a tendency of turning VMs, turning applications into monoliths if you're running on VMs. All right, so the second is CAS, and again, we have looked at the consistency, agility, efficiency, the benefits of CAS or containerization. the problems, like Cornelia was referring to the container image lifecycle management, right? Because the container image that you describe does not just have the source code, but also has all the base images, the language runtime, the OS, and any other dependencies packaged together. And this is created and pushed by developers. Now developers have the responsibility of doing the entire image cycle management. And this is where the next abstraction is really helpful, where developers are just writing code and the trusted container pipeline is taking care of building the containers. In addition to the image lifecycle management, an application abstraction hopefully will also bring in all the other things such as routing, observability, secret management that you don't have in container as a service or Kubernetes. So the good things on a PS, you don't need to learn OS, you don't need to learn Docker, you're not worried about patching containers. There's a separate team that's doing it. Very high developer productivity because you are focused on writing code, right? There's a very clear abstraction in responsibilities of writing code and operating and managing containers and the infrastructure. And no slow fix. Of course, with opinionated platforms such as PAS, there are constraints, right? And the constraints on the PAS is you can only run, you can run stateful, but it's really not meant to do that. You really have to conform to great practices, and there are protocol limitations, so TCP and HTTP only. With PFS, definitely resource efficient. You're writing very small piece of code. You are, the flexibility is less, but the efficiency is a lot more. So there's very high developer productivity, and you're decoupling your source code into really small pieces as functions. So very decoupled deployments. It's like nano services. Mostly suitable for event-driven, use cases, and the world is still evolving in functions as a service or function as an abstraction. So observability tooling is really not there yet. So there's obviously observability nightmare across functions, across services, and I know PFS team is deeply investing that if we want folks to adopt PFS, there's got to be observability tooling around that. But at the moment, it's definitely a nightmare. And the last bit is it's a significant redevelopment. Like think about how you have written applications and breaking them down into functions and moving into a completely new abstraction requires a lot of redevelopment. All right, so what is the right abstraction? And so now here we'll go in a little bit of details on which of, it could be a workflow or a sequence, like do you need X, Y, Z, then choose this abstraction. So that's what we'll look at here. So if you need kernel or OS customization, you got to go VM. If you have a really coupled code that you can scale only vertically, then there is a limit on how much a container can take. So it probably makes sense to go to a VM. If you need persistent local storage, whether it's a data service that's running and needs local storage, you have to go to CAS. If it's a software that you received from your vendor, from your partner, which is already containerized, then you are essentially a service operator in charge of running the container. So CAS is probably the right abstraction. If you have uncommon runtimes, if you have legacy stuff that you are containerizing, then CAS is probably the right abstraction. If you're running into any non-standard, non-specific protocol, HTTP, TCP, otherwise, then CAS would be the right one. And multiple TCP IP ports. This is very specific to PAS. If you have such requirements, then CAS is probably the right abstraction. PAS, very simple. Stateless, 12-factor apps, microservices. And like I said, FAS is still evolving. But what we see is web events as a starting point when you can start breaking down your application into smaller functions and using the PFS service. Bare metal, almost never. So if you went through, figuring out like which abstraction to use when, and if you still can't, find the answer, please start with PaaS. It's focused on developer productivity. It's been there, especially PaaS, it's been there, helping customers operate stuff in production for years. And for all the goodies that Cornelia talked about on security, malware, on-demand management of resources, please choose PaaS. That's how we recommend it to our customers. So a strategic goal for you as an organization, please try to push as many workloads at the top of the hierarchy, and wherever that's technically feasibly possible. And the reason being, as you go up, you have lower development complexity, but very high operational efficiency. And as you go down, you have exactly opposite. All right. That brings us to enterprise Kubernetes.
Excellent. Thank you, Mukesh. That was awesome. Really good. Okay, so what I want to close out our session with is telling you, I had promised to tell you a little bit about PKS. So the first thing that I want to talk about is not PKS's secret sauce just yet, but just level set on what enterprise Kubernetes means. So the Kubernetes open source project is a container scheduling software. So it basically says, hey, if I've got a number of machines that are going to be my worker machines, I'm going to go ahead and manage the dispatch, the scheduling of those workloads, and the availability, the resilience of those workloads on there. So that blue part is part of core Kubernetes. And then there's some tooling that's kind of arguably part of the core Kubernetes as well. So there's this kubectl CLI, as well as a Kubernetes dashboard, and maybe there's a couple of other things that you could argue are kind of part of core Kubernetes. And that's what the app team, remember the app team and platform team? That's what the app team uses. But that's not enough, because even if you were to download Minikube, Minikube is more than this. What it's doing is Minikube, which is the developer laptop Kubernetes distribution, it draws in a whole bunch of other things from your host, from the laptop itself. It borrows compute and storage and networking from the host itself. If you're doing this in a data center, of course, you have to bring all those things yourself as well: compute, storage, networking, routing, image registry, like Mukesh talked about earlier, et cetera, et cetera. And when you start to have that as a platform, you need some tools that the platform team is going to use to manage that. And that's what we're doing with PKS. Now, I would tell you that just about every Kubernetes distribution out there is doing this. They're pulling together core open source Kubernetes, hopefully. In some cases, they fork and extend. Stay away from them for sure. They're starting with core Kubernetes, and then they're bringing a whole bunch of other stuff and management planes around that. So let me share with you now what we believe our secret sauce is, the things that we quite intentionally put into our product because of some of the values that we've been talking about for the last hour. The first thing is, notice on the right-hand side, the concerns of the platform team include things like day one, installation, day two, upgrades, patch management, resilience. So remember the whole Throwback Tuesday thing that I showed you? So having workloads restart. But we need to do that for the platform itself, and that's where, second time I'm saying it today, that's where Bosch comes in. So what this first PKS secret sauce is about is, and I'm letting people take photos, is this: that PKS, and more specifically, Bosch, does for your Kubernetes what Kubernetes does for your workloads. So Kubernetes is constantly watching and making sure that your workloads are healthy, that you have the number of instances you've asked for. What PKS, and Bosch specifically, does is it does the same thing for your cluster. If you're running a 10-node cluster and something goes wrong with an availability zone and all of a sudden you only have 7 nodes, it'll recognize that and it'll bring your Kubernetes system back into a state where you've got 10 nodes. It also handles zero downtime upgrades. It's the engine that allows you to do, remember the malware, where we first talked about it in the container and then we talked about it at the host OS? Bosch is what enables that. So BOSH does for your cluster what Kubernetes does for your workloads. So that is secret sauce number one. You need something like BOSH to manage those clusters. Secret sauce number two is that in addition to BOSH taking care of the clusters that it's responsible for, the Kubernetes clusters that it's responsible for, I like to say it doesn't just look up, it also looks down, because BOSH is the abstraction layer to the infrastructure. So it is the multi-cloud. So PKS is multi-cloud. Currently, we support GCP and vSphere. We are shipping 1.2 later this month, and that's going to include AWS support. We're expecting Azure support by the end of the year. So we're really rounding that out, and we're very, very committed to the multi-cloud, because the initial feedback from customers is we are multi-cloud on PaaS, we need to be multi-cloud on Kubernetes as well. And then finally, the third secret sauce that I'm going to talk about, maybe four, depending on how you count, I'll make that point in just a moment, has to do with the tenancy model around Kubernetes. There's a couple of options. What people think about, kind of the knee-jerk reaction is, well, Kubernetes allows me, it's this shared environment, it's this shared platform that I can have all sorts of different tenants deploying things into, and Kubernetes does have the notion of a namespace, not to be confused with the namespaces at the operating system level. Same basic idea, multi-tenancy, but Kubernetes calls it a namespace. Now, the namespace support in Kubernetes does allow you to do things like put access control policies on the namespaces, so that if you're deploying, if you have access to one namespace and you can deploy into that namespace and see what's deployed into that namespace, you can't see what's deployed into the other namespace when you're using things like the Kubernetes dashboard or kube control. But there's a whole bunch of shared components in that Kubernetes cluster. Things like the shared compute, things like a shared network, shared DNS. So there's service discovery built into Kubernetes. There's one DNS. Shared configuration, there's one API server. And those things are not multi-tenant components. The DNS there is no notion of tenancy that is known in DNS. So even though I might, through kubectl, not be able to see what's in another namespace, if I go query DNS, I can see all of the services that are deployed across all these namespaces. Okay, so there's a whole bunch of shared components that are not built for multi-tenancy. What we do for this tenancy model is, with the addition of NSXT, and NSXT is software-defined networking, comes from VMware, and PKS is a joint project between VMware, Pivotal, and Google, is that, and by the way, NSXT is licensed as a part of PKS. You get to use it. It's part of the PKS license, is that we actually are replacing kubeproxy, which is the networking component. We're replacing kubeproxy with a multi-tenant version of kubeproxy. So Kubernetes is very pluggable, and what we've done is we've replaced kubeproxy with a multi-tenant one. Now, one approach to multi-tenancy might be to try to replace DNS with a multi-tenant DNS, replace the API server with a multi-tenant API server, and so on. And the whole point here is that on the left-hand side, multi-tenancy in Kubernetes today is very soft. And there's a great blog post by Jessie Frizzell of Microsoft. She's the co-lead, together with David Oppenheimer from Google, of the multi-tenancy working group that's addressing the fact that multi-tenancy in Kubernetes is very soft at the moment. What the leading proposal is within that working group, brought forth by Jessie in this blog post, is not to make each one of these components multi-tenant, but to have dedicated instances of each of these components per tenant. So your own API server, your own DNS. And that's something they're talking about and might deliver in a couple of years. We are actually delivering that today. And the way that we do that is that PKS is all about delivering single tenant clusters. So each cluster is its own tenancy, has its own API server, its own DNS, its own configurations, et cetera, et cetera. And what we do is we give you an API that allows you to manage a fleet of clusters. So when I talked about repaving the hosts, you can repave all of the hosts of all of your Kubernetes clusters through a single control. So that's pretty powerful. So you might be thinking, well, wait a minute, I'm going to have tons of different hosts? You're telling me I'm going to have hundreds of clusters? There's no way I can manage that. I'm going to have hundreds of different Snowflake clusters. And the answer is no, you're not. I'll draw your attention down here. There is, I can't find the laser pointer. If you look at the second to the bottom, it talks about plans. Plans are a way that you can create your template clusters so that you as an organization can decide these are the 3 flavors of Kubernetes clusters that are going to cover the workloads that I need in my organization. I'm going to create the security profiles and the configurations that I need, and those are the 3. So I won't have hundreds of different snowflakes. I'll have 3 different flavors, and I'll know how to manage those. So to sum it up, just to remind you of everything that we talked about here, is containerization brings value. It enables platforms to do even more, like patching operating systems, addressing malware, those types of things. There's lots of ways of getting to containers. So when your board says, we want you to go containers full bore, they're not maybe saying containers yet, they are saying cloud. Realize that that doesn't mean you have to go down to raw Kubernetes for everything. Many, many faces. And use the right tool for the job. And finally, here's that picture. Here's all those flavors. Functions on the far left, Kubernetes, PaaS, and then of course there's the services marketplace. So this brings together all of these different ways of bringing your organization to having 80% of your portfolio running in containers in 3 years, 5 years, I don't know. But this is the way you can get there. Thanks so much. I'm afraid we didn't leave room time for questions, but Mukesh and I will both stick around if you want to come up and ask some questions. Thanks so much.